So for those of you who have tried this, you might notice that this question is a bit complicated. Okay. Okay, so let's look at this. So form 6. Now look at what we have here. In an engine test, the dry product analysis was CO2 15.5%, O2 2.3%, and the remainder N2. So what you are told here is this. So for dry analysis, this is, so you have Y CO2 equals to 15.5%, YO2 equals to 2.3%, and Yn2 is 82.2%. Assuming that the fuel burnt was a pure hydrocarbon, meaning this fuel only consists of carbon and hydrogen. We don't know anything about it. Okay, so calculate the ratio of carbon to hydrogen in the fuel, the air fuel ratio used, and the mixture strength. So pretty much this is the only thing that you know, whatever that I wrote down here. Alright, so let's say if you try to construct a chemical equation with this. Actually, you can write two ways lah. Because just now you asked me the number of moles, right? So you can either assume this, you can just assume CHY, so for example, so X and Y is the ratio. If this is a little bit confusing to you, actually you can just write this also. You can just write X number of C plus Y number of H. Same thing lah, actually. It's just the same thing, so it depends on which one you prefer to see. Yeah. Okay. So let's say number of air of air is air is A as usual. Then O2 plus 3.76 N2. Okay, now the question here is how do we do, what do we do with the remaining gas? So we have CO2, we have H2O, we have O2, we also have N2. Right, but then we don't know what is the amount. Now there are actually a few. Okay, so let's look at the most obvious solution first, which is actually the most confusing one. But we'll look at it first. Okay, so let's say we don't know what's the amount, so we just simply give them some value. Okay, let's say B, C, D, E. So what you know here is this. YCO2 is B over B plus E plus E. Then same thing, then what's all the way you do this, right? So B over B plus E plus E, then Yn2 equals to E over B plus E plus E. We'll copy this first. I'm just saying this is the more obvious way when you look at it. But this is actually more complicated than you think. Because if you look at this, there's one issue here. You only have 3 equations and you actually have 4 unknowns. Right? Not really lah. Here is 3 equations, 3 unknowns. But actually if you try to balance them, you have to assume certain number for them. Otherwise, right, it's actually very hard to solve one. If you just look at this one, you do have value for that. But then the value here is actually very complicated to solve. So what you can do is actually just simplify the entire thing. You don't do this. What you do here is this. You assume you have 100 kilomole or 1 kilomole of dry product. As usual lah. So you just assume 100 kilomole of dry product. So what you get then will be then you can put in any number. Because right, even if you try to solve the above 3 equations, ultimately you still need to assume for one of them. Otherwise it will be very hard for you to solve as well. So might as well you assume 100%, 100 kilomole of dry product, or 1 kilomole, whichever one that you like. Then you can straight away write 15.5 CO2. Of course, you still have an O2, so you should still have a variable for O2. Then 2.3 O2 and plus 82.2 and 2. So this is based on if the total. So this basic pretty much this is actually the same, but here we are assuming B plus D plus E is 100 kilomole straight away, because ultimately the whole equation is just a ratio, right? So yeah, then now you have some values, then you can solve this question. So after that, all you need to do is you balance everything. So C, so X is 15.5 in this case. Then Y is, sorry, this is not Y, this is H. H is Y equals to 2C. So we don't have this value yet. Look at O, you have 2A equals to 15.5 multiplied by 2 plus C and plus 2.3 multiplied by 2. And N or N2, whichever one that you are comfortable with, 2.76A equals to 82.2. So from here, you can get A equals to 21.8617. Then you go backward. So from here you can get C, and here you can get Y. So this should be the value. So from here, we can see that the ratio of carbon to hydrogen would actually be, so carbon here with 15.5, hydrogen is 16.2468. But there's one issue here. So for some reason, I think the question isn't very clear. The answer here that they are looking for the ratio between carbon and hydrogen is actually in terms of mass, not in terms of mole. So, meaning what you need to do here is, you need to multiply by the molar mass. So, meaning here you need to multiply by 12, here you multiply by 1, then you will get the actual ratio. So, this ratio is actually by mass. So, you get 11.45 kg of carbon for every kg of hydrogen. So let's say if I really ask this in exam, I will make this a bit more clear because I think it's not bad also because you just say ratio, right? So it doesn't really specify which one is which. So once you're done with this, then you can find the air-fuel ratio. So air-fuel ratio, just repeat what you usually do. So for air, you have 31.8617, 4.76, 29. So at the bottom here, yeah, it's just the total. So from 16.52 plus 16.2468. So this should give you 14.92 over 1. Okay, just write the whole thing now. Oh, because I wrote wrongly. Well. Mixture strength. Okay, so mixture strength, we know that what we have is the stoichiometric amount over the actual amount. It can be, you can use FU ratio, you can use amount of air, they are the same thing. Because ultimately the amount of air is the only thing that changes. Right? So which means, what do you need to do here? Yeah, so you need to find the ATH. So yeah, it's just a reverse of what you usually do, basically. So there now, so you need to find ATH here. So to find ATH, so now you know the amount of carbon. You know the amount of hydrogen. And you can just write up 15.502 and then 8.1, 2, 3, 4 H2O. And this time no more O2 because to find stoichiometric amount, you always assume complete combustion with no excess. Here. So here you should find that ATH. I will show the whole balancing line. This one you try. So you should find that ATH is 19.5617. Yeah, actually you just minus by the possibility. That makes sure strength is just ATH over A. And they should give you something like this, so 89.6%.
Mixture strength is 80 over 8, is it?
Mixture strength?
Over
Yeah.
9.
So mixture strength is basically the opposite of your percentage A. So it's the stoichiometric over actual. So whenever I write stoichiometric over actual or actual over stoichiometric, you can either use NP ratio or you can just use amount of A, because that's the same thing. That's the only variable there. The others are all constant. Pretty much it's the same type of question, but slightly easier because you are told decay rather than a random kind of problem. So, and also, I think this one, I won't discuss, you try yourself, but this is one type of question where you can see actually from the product itself. Okay, let me ask you two questions from this question. I let you try, but I ask you questions. Do we have excess A here or deficiency of A?
No.
No, which one?
Dry A means.
No, dry A doesn't matter. Dry A always means O2 plus 2.76 and 2. That's all. Efficiency and why? But you have O2 also.
Dry.
Yeah, so so deficiency of A. Excess A. So this is a case of excess A, but incomplete combustion. This can happen because if you look back at your lecture notes, we listed out a few reasons or a few factors for incomplete combustion. So incomplete combustion is not just a result of not enough air. It can also be you didn't burn enough, long enough, not hot enough. Those can also be the reason. So this case actually is a case of excess air but incomplete combustion. Otherwise, the way to solve this question is exactly the same as problem 6. So you can try this out on your own. And this is also easier because you have CH4 rather than an unknown hydrocarbon. You know the composition exactly. So now maybe we do problem 8. Problem 8 has something new that you have never learned, but I did mention a little bit before this. So here you have an octane with it, and it's burned with 60% excess air, with 15% of the carbon in the fuel forming carbon monoxide. Okay, same thing. So you can see here excess air, but incomplete combustion because you get carbon monoxide. Calculate the mole fractions of the product. Meaning this one, if they say it just says mole fraction of the product, so every product most likely is wet analysis lah. So if you need to find the mole fraction for everything, then it will be a mole analysis. And the second part, of course, you wouldn't have studied this. You need to find the dew point temperature of the water vapor in the products when the products are at 1 atmospheric pressure. Does anyone still remember what is the dew point temperature? Yeah, the one that I said, the temperature at which actually basically the temperature at which the water vapor in the air will condense. That's pretty much the simple version of it. So here, actually, it is not in your syllabus lah, but this question has it, so I will show you. In a way, probably it will make a bit more sense to you also why the temperature is different when it condenses. So I will show this question. Because condensation temperature is usually just saturated temperature, which means it's supposed to be 100 for most of us, right? Okay, but now when we look at the early part first, so our indication. So we have octane. Which is burnt with 60% excess air. So how much is 60% excess air? Of yeah, so meaning you actually supposed to find the ATH first. So again, sometimes there are situations where you can actually just solve without the ATH, but to be safe, maybe for me, even if it is an extra step, maybe you practice the habit of finding ATH first. Meaning to find ATH, you need to assume complete combustion. Just like the previous question. So just one extra step. So you find the ATH. So again, don't need to put too much attention to the term dry air, because dry air basically just means this thing. This is dry air. So if we assume complete combustion, then it is just CO2 plus H2O plus N2. One by one. So X, Y, Z. But actually by now you should realize that X and Y actually you don't really need to balance that. You also know the answer because you just C and H. So C, if you balance C, X will give you 8. If you balance H, Y will give you 9. Then we balance O. O will be 2ATH, 2X plus 2Y. Sorry, Y. So ATH here will give you 12.5. And then N2 Z is just 3.76 ATH, right? This one. Okay, then now we go to the question. So meaning so now we go back to what the question gives you. So the question, so once again we write back this. Now we know what is the value of ATH, so this is 1.6 multiplied by 12.5. Then O2 plus 3.76 N2. %. So 60% excess air. Now we have CO2 plus CO because you have carbon monoxide. And we have H2O. You also have O2 because you have excess air, remember? And then maybe N2 I'll just write at the bottom. So N2 is just N2 very long. This is. So this N2. Okay, so how much CO2 do we have and how much CO we have? So question mentioned that 15% of the carbon becomes carbon monoxide. So which means for CO2, this will be O multiplied by 0.85. And for CO will be 8 multiplied by 0.15. Because 15% goes to CO, which means 80% goes to CO2. H2O, actually nothing should change. H2O should be still the same because H is burned completely. Then whatever that's left over is O2. But of course here O2 is not as straightforward as just the air minus ATH, unlike the previous question because it's in complete combustion. So this one safer, to be safe, you balance O2. So for here, O you balance. So here, this is 2 plus 8 plus 9 plus 2x. So here should give you x equals to 8. It should be around this way. So this is the amount of excess air. I mean the amount of oxygen that you produce. Everyone clear so far? I will move down a little bit. So you need to find the mole fraction of the product. So this one should be wet analysis because we want the entire product. So for wet analysis and total product, you need to find everything. So the number of moles of the product total will be the total of everything. So the total of everything should give you about, what's the total number of moles? If you just press this for the product. So this one you need to include water, okay? So then you can calculate each of them. This one you can try. So this should, I will just give you the final answer. So this should give you this. Okay, so just like what I usually say, you can see that N2 is N2 always has the largest portion. So like in this case, this is N2 is about 75%. Compared to the rest. So the rest, the maximum also, even the maximum is like less than 10% for the others. So if you realize that your other component it has a very large percent, then you know somewhere it's wrong. So here, if you total them up, you should get 100% as well. Or 1, if you use the value directly. Mole of the product. Okay, now we move on to look at dew point and temperature. I think this one is extra. So dew point temperature for this product. Now, like we say, dew point temperature is the temperature when the water vapor can condense, right? So in a way, this is actually the saturation temperature. Of the water vapor. Alright, so why is this value not just simply 100 degrees Celsius? Because your air or atmosphere is just 1 atm, right? Because the water vapor itself is actually not at 1 atm. So if you just look at this question, we say that we assume the product is at 1 atm, right? So P of the product is 1 atmospheric pressure, so it's 101.325 kilopascal. But if you look at the number of mole of the water in the product, okay, the Y of H2O is actually just, so the mole fraction of the water is just, what is the value of 9. So it's actually just 9 over 100.3. Which means, right, water is only this amount. And so, we can actually find the partial pressure of the water in this 101.325. Right? Basically just multiplying this up. Because we learned that the pressure fraction, volume fraction, mole fraction, and volume and mole fraction, they are all the same thing. So by doing this, you can find the pressure of the water vapor, the partial pressure of the water vapor. Okay, so if you find the partial pressure of the water vapor, in this case, this is about this value. So it means that, in a way, the water vapor itself is only at 9.092 kilopascal, which means the dew point temperature of the water vapor will be the, so which means T dew point is actually T saturated at 9.092 kilopascal, like in this case. So rather than atmospheric pressure, it is actually just 9 kilopascal. So that's why their water can condense even though that the temperature is not 100 degrees or something like that. Or rather, you can think about it this way: if the water saturated temperature of the water vapor is at the atmospheric pressure, right, which is 100 degrees Celsius, which means everywhere is water, liquid water, you won't have any water vapor. So why are the temperature different? Because it depends on how much water you have in the air, then the saturated temperature and pressure of the water is different. So in this case, so something like this. You refer to the law to interpolate between, but I don't know which one table to get over. The pressure is really low. You can check. Should have lah, because temperature, the answer here is actually 44 degrees Celsius. I think the table should have. Yeah, the table start from 1 kilopascal, so 10, like maybe we interpolate. When will your exam timetable comes out?
Weekend.
The weekend, next week. But so you know already.
And tell us.
I got bad news lah. Evening paper.
Oh. But the time, the date is which one? Which week? Because we have 3 paper only.
Oh. Your paper is not late one. Not late paper.
First week, 2 week.
I don't know how to consider first week. The exam starts on Tuesday again or Friday. Because last time start on Friday. Now I think they start on Tuesday. It start on Tuesday, then your paper is second. It's not late now. It's definitely not the final week. Not a late date. But it's a evening paper. It's not you actually to yourself. I don't know whether we change or not. The date that I have is evening paper, unfortunately.